So we're going to move to the next session, which is an intro to IPFS and Falcone with Nikki and Konstantin. I'm going to invite both of them to the stage.
Hey, Carlos, could you please enable video?
Sure.
Hi.
There you go. Hi, Nikki.
Hello, everyone.
Hi, awesome. Excited to be here. Should we just dive in?
Go ahead. The floor is yours.
All right, awesome. Hi, everyone. My name is Nikki. I work on the ecosystem growth team with Filecoin and IPFS. And I'm just quickly going to share my screen. Feel free to post any questions on the chat. We will get to them at the end of my talk.
And in the meantime, I will try to answer or point you to the data if something is urgent on the Q&A. So feel free to also drop any questions there.
Yeah. Are you able to see the right slide? It says Introduction to Filecoin and IPFS.
Yeah.
Yes.
Okay, awesome. Cool. So I'm going to cover a few of these things.
Sorry,
that you...
Nikki?
Yeah?
We see the presenter view, not your...
Okay. Hang on. Do you see it now?
Right now, we see the agenda without the presenter view.
Okay, cool. Awesome. Okay, so let's quickly get started. So we're first going to talk about the core concepts of IPFS and Filecoin. What are the building blocks that make it possible for Filecoin to be what it is, and how does IPFS work? And then we'll go through some of the tools that make it easy to use IPFS and Filecoin, and what are the different possibilities with the technology that we have. And I'll link you to some of the learning resources. Okay, so let's start with what's this current problem that we have with the internet today. It's centralized, and there's like lots of single points of failure. I'm sure you have seen a few times when either Facebook or a website has been down because their servers have been down. Information and data are really important, and they should be preserved in a way that is more robust and more future-proof than what we have today. So what's the alternative to that? We could have either a decentralized system, which is, a little better than the centralized version with multiple nodes, and or we could have a fully distributed system where all the peers are connected and it's effectively a peer-to-peer network. Yeah, so we are going to talk about how IPFS, which is the last one on the slide that you see, a peer-to-peer network that makes it possible for a decentralized, robust, a distributed, robust architecture to make our internet better than what it is today. Okay, so IPFS is Interplanetary File System. Now, why, first of all, what's a file system, right? Simple collection of different files and folders. And why do we call it interplanetary? The idea is that if you were on Mars and I was on Earth and you needed a file from me, it would take a very long time for you to get it. But if somebody on Mars already had that file, then it would be pretty easy and pretty quick for you to retrieve it. So of course, we don't have to be on different planets to use IPFS, but the idea is that with this peer-to-peer network, there are no central servers, and even if a small part of the network was to go down, the rest of the network will not be impacted by it, which is not the case in today's centralized version of the internet. So how does the internet today work, right? Today, say, before we get to the internet, so how are files stored on our computer? You store a file and you see the address of that file, which is on your hard drive. On the web, it's not very different. There, it's the location of another computer a few miles or a few thousands of miles away. And whenever you write down a URL in your browser window, you are effectively typing out the address of the computer from where you are retrieving the file that you want. In IPFS, we change this location-based addressing to content addressing, and we use something called a CID. And I will dive into what a CID is. So what's a CID? CID is not the location of where a specific piece of information is stored, but rather it's a hash derived from the content itself. So if you had the same file, it will always give you the same CID. And it can be reproduced anytime because you are effectively just running a hash function, and it's very quick and easy to run. And also, what it ensures is verifiability. So for example, if I retrieved a piece of information using the CID, when I get it, I will easily be able to run the hash again on the content I have received and make sure that it's the data that I had requested. So we use CID for addressing in the IPFS world as opposed to location-based addressing. Now we talked about files and folders. So what's a folder? A folder will be nothing but just a list of files. So it is just another a special type of file. And hence everything that we talked about, a CID, can just be applied to a folder, which is another file. So now how is all of this stored? Now, if say I had a bunch of, if I have a folder system, the type of which that you can see on the screen, so you can see that my main folder has a root CID. Now that folder is a file which has two references, one to a folder system, which is a folder which has three files that you see, and the other one has just one file. Now, each of the four images you see, we have generated like a unique fingerprint. The content ID is a unique fingerprint. So every file will always have a unique content ID. Even if a pixel in any of these files were to change, the CID would change. Now, as you can see, you have two folders that are linked in the file that in the folder above, and then it links to the CID. Now, and this is stored in a structure called the Merkle DAG, or a direct acyclic graph. That's nothing but just a type of tree structure in which the entire file system is stored. Now, for example, if we wanted to say move a file from one folder to another folder, we don't have to replicate it, because all we have to do is just move the CID from one file to another, and that's it. Like, you're done, which we call as deduplication. And I already talked about the verifiability because of the uniqueness of the hash that is generated, which becomes the CID. Our content is verifiable. So now we talked about how each piece of content is uniquely identified by a key. But how do we like actually make it possible that they are discovered? Like, how do we make these pieces of information move from one peer to one node to another? So now let's look at this, right? This is each node in the IPFS network, we call it a peer, and each peer has a unique cryptographic name called the peer ID. And information from one peer to another is sent via cryptographic encrypted channels. And we make sure that all of this is discoverable using something called a DHT. Now, how does a DHT work? A DHT is nothing but a distributed hash table. So all the nodes put together will have one will have the entire table, but not every node will have, every node will only have a part of it, not the entire table. So, and what will it have? It will have a list of keys and values, and all of this will be maintained by multiple peers. So when I'm trying to find a piece of information from a CID, I will reach out to the peers close to me on, hey, whether you have this, whether you have the file addressed by this CID or not. And keys and the peer will look it up in the part of the table that it has, and either send you back the content or figure a way out to actually find the peer where the content you're looking for is addressed. So each table will have either a content ID or a peer ID, and peers are able to add rows to the DHT, declaring either their peer ID provides a specific CID, and then how to connect to the peer ID. And peers can query from the DHT to find which peer is providing the content they need. Cool. So now we've talked about how we are addressing files in the IPFS system, and how we discover the content, how content routing works, and then and now let's like zoom out a little and see, so what does the distributed system look like, and how can you do it? So for example, if I want to host data that I want to save, I can run an IPFS node. But if my node is down, if my data center is offline, then or my computer is offline, then that piece of data is not discoverable. So then I can choose to run a bunch of nodes and maybe a big infrastructure of data centers and make sure that the file is always retrievable. The other options are, we can use a pinning service like Pinata, which makes sure that they have a bunch of nodes running. And as long as that is up, your data that is pinned, that is available on any of the nodes is discoverable. And the other alternative is also that you hope that your data becomes viral or like popular enough, and it is stored by multiple nodes and always retrievable. And as long as the file is available even on a single node, it's going to be discoverable because this is a distributed network and everything is addressed by the CIDs. However, running an IPFS node does not guarantee that the data is going to be available. So this is a good way to good place to segue into why we need Filecoin. Filecoin is storage designed specifically for Web3, and it is fully compatible with IPFS and Web3. And it is built on top of IPFS, and it integrates with a whole bunch of smart contract chains like Near, and we are working on building bridges to multiple other chains. And this storage is verifiable via cryptographic proofs, and I'll get into more details about it. But these proofs ensure that once you store data on Filecoin, any of the Filecoin storage providers, then it's going to be there, and it's going to stick to the rules that you define for your storage deal. And there's incentives and also penalties for storage providers for storing or failing to store your data respectively. And it's the biggest decentralized storage network that we have, with 15 exabytes of capacity spread all over the world by multiple storage providers. And it's not run by a single company like a typical AWS or a Google Cloud with single points of failure, but it's actually a network of multiple storage providers. Okay, so how does Filecoin exactly work? So once you decide to store data on Filecoin, you will make a deal with one or more of these storage providers, and everything that we talked about, the CID, making it discoverable via DHT, all of that happens, and your data is stored on these DAGs, and it is stored across one or more of the storage providers. Once you store it, they provide an initial proof of replication that the data that you uploaded is actually replicated in their server, and it is published to the Filecoin blockchain. Over time, you have proof of space-time being shared, which is like a verification, like a message saying that, hey, yeah, your data is fine, and they're mandated to provide this periodically. Otherwise, there are penalties on not being able to furnish proof of storage. And you can choose what kind of deal you want. You want your data to be stored for 5 years, 15 years, 5 months, 100 years. It's completely up to you. And you can renew the storage deals and define the rules for it. So yeah, this is what I'm talking about, right? So you decide to have a storage deal. You can say, I want to store my data across 2 or 3 storage providers, creating backups. And since the cost of storing is substantially low, it's easily possible to like replicate data storage. You can choose to continue renewing your deal forever. And if you want permanent storage, that's completely possible. You club Filecoin with a specific type of smart contract, and you have permanent storage. Often we don't always need permanent storage, and we just want data for a few months or years, and you can code that into the smart contract as well. And by the way, IPFS is storage layer agnostic, right? So if you are using IPFS, you don't necessarily have to use Filecoin, but Filecoin works great with IPFS, and it's possible to do any sort of combinations that you like, right? You can choose to store data on like 2 Filecoin storage providers, have 2 deals running with 2 different storage providers, and upload it to the cloud, or just have one version on the cloud, one on a Filecoin, and have a Filecoin deal going. You can also decide to like move it at a later point. And because everything is like content addressed, it's very easy to move. So this makes it very modular, and you can choose to define your storage deals the way you want. And yeah, so that's it. So IPFS works great with Filecoin. IPFS is great for fast, flexible retrieval, and Filecoin gives persistence and verifiability and a guarantee that your data is going to be available depending on how it has been written in how the deal has been defined. So that was the section on IPFS and Filecoin. And Konstantin, are there any questions that we want to take at this point, or should we go on?
Everything is good so far. I think all the questions that are arising have been answered. Awesome,
cool. So now I will jump on to the tools that we have. I won't spend a lot of time in detail because we have a couple of sessions exactly to go through all the details, but I will talk about them briefly. So now we have talked about all the awesome concepts of IPFS and Filecoin, but it's kind of hard to directly interact with these protocols. So what we have is a whole layer, the yellow one that you see up there, called storage helpers. And they basically interact with IPFS and Filecoin and give you easy APIs and SDKs to make sure that the storage layer is easy for you to use, and you can focus on building everything else related to your project or your application. And this simplifies deal making, and it also ensures persistent and verifiable data for your application. So one of the services is Fleek. We love Fleek. Our website, hackathons.filecoin.io, is built using Fleek as well. And it's a super easy way to host websites on IPFS, and come on, everybody needs a website, no matter what you're doing. Yeah, it's pretty easy to use. It can be easily connected with GitHub, and you can add whatever settings you want, and it can be deployed to IPFS and backed to Filecoin. The other one that we have is called Web3 Storage. It's for any type of data storage that you want on Filecoin and IPFS. Data is uploaded to an estuary node. It's an IPFS plus Filecoin node, and it also replicates across 6 storage providers around the world. So the different kind of models that we talked about that you could have, it's possible using, one of them is replicating your data across 6 storage providers, and that's possible with Web3 Storage. Then this one is pretty special, especially designed for NFT developers. And you can back up any data using IPFS CID, and storage plus retrieval is free. That like free storage is available to use this directly as part of your project. And it's pinned to 3 storage providers, and it's backed up to Filecoin with a redundancy of 5 storage providers. This is another one, if you want, called PowerGate. It's easier. It's for those who would like to have a more powerful interface with IPFS and Filecoin and tinker around a bit more. And we already have bridges to Near, and a couple of others are on the way too. So that was on the tools that we have, and we will have a couple of sessions, one by Konstantin, another by Ali, which get into the details, and they'll actually do a deep dive, and Ali will do a code along for NFT.storage and Fleek, and how to actually use those in your projects. Cool. So yeah, if there's anything I want you all to like remember out of this session, it's this: all the amazing features that come with IPFS and Filecoin are at bottom layer of the stack. You have all the different storage helpers, which can help you to write any type of smart contracts or use any of the different logic chains that are available, be it Ethereum or Near or Hedera or Chainlink. And we have something very special called Filecoin Virtual Machine coming up too. It's currently work in progress, but that will allow us to have programmable storage. And then it can have any sort of front end. It could be a Web 2 interface or a Web 3 interface. And I won't spend much time on this, but these are a bunch of ideas around different applications that are possible with Filecoin and IPFS and any other different tool that you choose to pick. And there's also a lot of, for inspiration, we also have our past hackathon winners published on our hackathon's website in the Hall of Fame. There's a whole bunch of them, and you can take a look at them for inspiration and see what are the different ways they've used different technologies to come up with their winning projects. I'll post the link to it in the chat. And we love supporting developers who are building on IPFS and Filecoin. We have our Discord, Slack. You can find us on Twitter, on our websites. And you can also block office hours with one of our developer advocates. Konstantin is one of them, our superstar. And just like feel free to reach out and post your questions, and we're always happy to help. And that's it from me.
Awesome. Thank you, Nikki. And I would just encourage everyone, if you still have any questions which were not answered yet, just drop a line in the chat, or we'll be happy to answer all your questions regarding to the IPFS, Filecoin. I think Carlos and we will be also happy to just generally guide you through the process of this hackathon, both here on the online calls or in the Discord channel. So we're more than happy to share all additional information. If you have any ideas on your hackathon topic, or you just have some questions or doubts how it will work the best, feel free to reach us out, and just we'll be happy to navigate you through the exciting world of Web3.
And we are handing out swag for anyone who asks questions.
So you have an additional motivation to be active during this hackathon. So are there any other questions which I'll be happy to answer? You can either drop them in Q&A or in the chat, and we'll be happy to elaborate on that. Thank you for the question, or thank you for the comment. I think, to my knowledge, it's already available on some repository. It's not development from IPFS or Protocol Labs directly, but I think there are already functionalities which allow you to download from YouTube directly on IPFS. And I will just look for through the GitHub repositories, and you'll definitely find the solution already. But generally, I would definitely say that preserving some of the data or copying some of the data from Web 2 to Web 3 is just generally a good use case. And there are things which you want to store and you want to reliably have access over time. And that could be one of the definitely use cases for any project on a hackathon, just to build a connector tool which will allow a transition from Web 2 solution, which already exists, to a Web3 and decentralized storage. So you're more than welcome. And yeah, just excited to see different projects from you. Also, feel free to look into our GitHubs, and there are a lot of projects, a lot of issues happening, and generally the IPFS and Filecoin GitHub is a great community where people can collaborate. It's open to everyone to contribute, and we also check a lot on people who are contributing. So by adding something you developed, if you found a bug, if you found a problem, feel free also to post it. It's really open, and as we are a truly open source community, so we encourage everyone to participate. And we also have, if you are looking for something, we also have open positions in Protocol Labs, which you may be interested in joining during or after the hackathon. So we are excited to see new faces, new Web3 builders, and regardless of the path you're planning to take, either the startup or project, or it's just a training opportunity for you, there is a lot of people who are ready to help you on that way through your whole project lifetime.